Hello everyone, I'm Dr. Aisha Qureshi from Boumerdes University of Wurgla. So today I'm going to present our contribution titled Enhanced Two-Stage PCA Net for Biometric Recognition via Discriminative Block Reweighting and Overlapped Histogram Encoding, presenting as a part of the A2I25 conference. So during this presentation I'm going to follow this plan. Firstly, I will start by the introduction and the work background. Next, the problematic followed by the related work and some motivations. In the fourth part, I will talk about exactly our contributions, followed by a discussion of the obtained results. And finally, I will conclude this presentation with a conclusion and some perspectives. So, firstly, I will talk as our contribution is about biometric systems. So, firstly, I will explain what does a biometric identification system means. So, identification seeks to identify an unknown person according to their biometric traits. So, the system attempts to answer the questions. Who is this person or who generated this biometric? So identification systems are described as 1 to n matching system, where n is the total number of biometric traits in the database. So the system should answer the question, who am I among the n person? So, several biometric traits are existing, divided into two subcategories, which are the first category is about physiological traits like face, fingerprint, iris, ear, and the retina. And the second part is about behavioral traits such as voice or signature. So, in this work, we focus on the ear. So, we focus on the ear for several reasons. So it's stable across the age and expressions. So the ear, as it known, is unaffected by the facial emotion or masks, and it offers high interperson variation. So we talk about the exactly problematics. So when we analyze the existing work, most work in biometric system treat all image region equally. So however, not all region carry the same discriminative information. So this is exactly our problematic. So given an image, it's not necessary that the all images present the ear or even any biometric traits. So by analyzing also the existing solutions for ear identification based system, so we categorized the existing approaches into 5 subcategories. So for geometrical based methods, holistic and hybrid or deep CNN based methods, and texture based methods. So, and this table summarizes some existing work on the ear identification system. So by analyzing the existing works, so we will mention some limitations based on the category groups. So the performance of handcrafted features is generally limited on constrained scenarios. So the performance of handcrafted methods tends to considerably decreases as the size of the data set increases. So it's well known that deep-based schemes are data hungry, and they may require a great deal of time to perform feature learning and extraction. So especially for the networks with high number of stacked layers and a huge number of parameters. So what is our contribution? So among the existing solutions, we mention a holistic approach. So a holistic approach, from one of the most performant models is PCA net. So we take this model and we try to improve an existing PCA network based on the limitations. So we propose an overlapped block histogram and encoding. So as PCA net, the original PCA net doesn't take any care about the regions. So we propose a discriminative block weights, and the system finally will improve it. So as our contribution is based on existing PCA network, so we will first explain the architecture of this PCA net. So the PCA net contains mainly three steps. The first step is about PCA filter learning, bank filter learning. Then after learning the filters, so the next step is the convolution layer with the PCA filter. So this convolution layer can may include one or two or three layers. So for this reason, I mentioned in our contribution, we mentioned two stage. So by stage I means the number of layers used for in the convolution layer. So the third part of the PCA net architecture is the binary hashing and the blockwise histogramming. So finally we propose as a contribution also as is already published the effectiveness of TR normalization and concatenation. So the first stage of PCA net architecture is about filter bank learning. So we will explain what happened exactly in this stage. So given an image patch L of size m by m and a set of filters of the same size, the filter are estimated by maximizing the retrained variance of the projected responses as the following equation. So then PCA decomposes the filter matrix W using eigenvalues decomposition of the covariance matrix as the equation also. So V is the matrix of orthogonal eigenvectors capturing directions of maximum variance. So the next step if after convolution layer is the binary hashing and the blockwise histogramming stage. So for each input image LE, there is D by M output corresponding to the number of convolved W filters with the D channel of the input image. So the output are binarized according to a binarized function where f function is defined with this equation. So when the values is minus than 0, so the encoding with 0, and if it's superior than 0, so the function give it 1. So a decimal value DE is associated to the string code corresponding to each pixel filter response, where each pixel value is an integer in the range 0 and 2 as the following equation. So the image is divided into B known overlapped. I'm talking about the original PCA net. B known overlapped block. For each block, compute a histogram which is denoted by HDB, noting that each histogram has 2 and beans. So the final feature vector is obtained by concatenating the histogram of all blocks. So as I mentioned also that we propose in already published work, the effectiveness of tide rank normalization. So we propose also in this work to use this technique as histogram normalization. So based on tide rank, and this figure illustrates the algorithm of the tide rank normalization. So next, I'm going to exactly explain the architecture of the proposed system. So as the figure below. So the system first, the system receives a grayscale image as input, then PCA as first stage of PCA filters extract the local features using PCA filters applied to image patch. So in the next stage of PCA filters, an enhanced representation by applying a second layer of PCA on the output of stage 1. So next, after the two layers of the PCA network, so we pass to the next stage, which is a binary encoding, which converts features maps into a binary patterns. So next we will pass to an overlapped block histogram encoding, which generates histogram for overlapping blocks to capture exactly the special structure. So the next tide rank normalization, it normalizes block histograms to reduce the magnitude bias. So the discriminative block reweighting assign weights, and this is the key, most important for our contribution, is to assign weights to block using class separability score, which is the Fisher scores, and then finally combine all weighted block histograms into a one feature vector. So the final stage of our proposed system is the classification. So the final descriptor is fed into a classifier each for the recognition. So in order to improve the performance of our system, since our system doesn't rely on full CNN, we highlight that previous work often uses CNN based pre-processing. We focus on achieving similar or better performance with less computational cost. And the table below illustrates the architecture of the CNN-based image pre-processing and the results before and after applying this architecture. So we pass now to the experimental results. So we use the AWE dataset for which contain 1000 human images from 100 different persons, so 10 images per person distributed between males and females from different ethnicity and ages. So one of the most key important of the the challenge of this data set is that the images are taken from uncontrolled conditions in the wild, so with different size, varying illuminations and different viewing angles. So, and the two images illustrate the results obtained by. So sorry, the figure illustrates the results obtained. So as our objective is to improve the original PCA net, so it's logical to test one by one our proposition. So we will mention the results of PCA net, just the PCA net, so, and that test the performance of adding overlap only and adding reweighting only, and just by adding PCA net tide rank, and we compare the obtained results with other existing models. So the baseline PCA net achieves 82.5% accuracy on the AWE dataset. So adding an overlapped block histogram encoding improved the spatial representation, boosting accuracy to 84.1%. So while integrating discriminative block reweighting further improves class separately, reaching 25.3%. So the addition of tied rank improves the robustness of histogram skill, contributing to 83.6. So the combination of all enhancements yields to the highest accuracy, which is 27.3%, outperforming the TR PCA net, and the TR ECA net. So let's analyze together the results. So why tied rank yields to good results, and the proposed discriminative block and the overlapped block. So firstly, I will start by the overlapped histogram encoding. So it captures richer spatial information by allowing regions to contribute to multiple blocks, which prevent loss of discriminative edge or texture info of block boundaries. So the discriminative block reweighting uses a Fisher score to emphasize blocks that are more class separable, so which boosts the influence of informative regions over non-discriminative ones. So and tied rank normalization normalize across blocks with different histogram magnitude, which reduce the bias from blocks which naturally stronger response, improving feature balance. So together, of course, they yield to a well normalized discriminative future vector, boosting final classification performance. So as a conclusion, we mentioned that we proposed an enhanced two-stage PCA net based framework for air biometric recognition. So the system integrates three key innovations, which are overlapped block histogram encoding, tied rank histogram normalization, and discriminative block reweighting. Extensive experiments on the AWE dataset demonstrate that each enhancement contributes to improve the recognition accuracy. So the proposed method achieves 87.3% outperforming both baseline PCA net and other TR PCA net variants. So these results confirm the effectiveness of combining lightweight learning PCA net with simple yet powerful post-preprocessing to improve biometric identification performance. So thank you for your attention and listen, and here is my email for any contacts.